I'm not going to do a big review. I think we all know what we've been talking about. It's been trig of any ratio. We've learned type 0, type 1, type 2, and now we're on to type 3. And by now, actually, you're going to be really comfortable with this because we're just using all the different techniques we've learned to talk about type 3. In type 3, if you take a look at the sheet and you look at the examples, you're going to notice that we have our first example, for example, is sine theta is equal to 2/3. So how does this differ from type 2? What did we have in type 2? Yeah, so in type 2, remember how we had a decimal? In this one, we're going to have a fraction. So we're going to be actually able to answer a couple more questions in this. And how does it differ than type 1? Well, in type 1, we didn't have any ratio given at all. We just had an angle. So type 1 is an angle. Type 2 is the ratio as a decimal. Type 3 is the ratio as a fraction. You can take a look at the steps for success, but really it's very, very similar to what we did last class. So I'm just going to get started and we're gonna solve this. So the first question is sine theta is equal to 2/3. Just like before for type 3, you are going to have two answers, and we will be using calculators for this. So what we're going to do is we're first going to convert the theta into a beta, and if 2/3 was negative, we would make it into a positive. All right, so let's begin by going sine beta is equal to 2/3. Use your calculator and figure out what sine inverse of 2 divided by 3 is. And we're going to just go ahead and round it to the nearest whole degree, which is going to give me 42 degrees. Beta is equal to 42 degrees. Now we have to use the cast rule and figure out what two quadrants this is going to belong in. We're going to look at the original question to do that. Marzouk? Yes. Yes. So remember, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And according to CAST, C-A-S-T, if in my original question sine is positive, which two quadrants is it going to appear in? Yeah. Perfect. So quadrant 1 and quadrant 2. And hopefully you guys remember us doing this all last class. So like I said, there's a lot of repetition in today's lesson. So this is going to be quadrant 1 and quadrant 2. Go ahead and draw your lines. We're also going to put in our related acute angle, which is beta, and you just picture the little bow tie, and you're going to know it's going to belong right in here, and it's going to go right in here. Now let's read the question. The question says, given each trigonometric ratio, determine the exact values of x, y, and r, the related acute angle beta, and the principal angle theta. Let's start off by figuring out the thetas, because we kind of did that already last class, so that'll be more review. We already have beta, it's 42 degrees. We're now going to draw our first arm from the initial arm to the first terminal arm. We're going to call that theta 1. And then for the second arm, we're going to go from the initial arm all the way to the second, and we're going to call that theta 2. We're going to come to the side. We're going to figure out theta 1 is 42 degrees. And we're going to figure out theta 2 is going to be 180 minus 42, which is going to be 138 degrees. All right, you guys notice that this is exactly the way we did it before, right? The only additional step in this question now is we want to figure out what our side lengths of these triangles are. They're asking us for x, y, and r. So what we're going to have to do is we're actually going to have to make the triangle. Again, think back to the bow tie. And we're going to have to figure out what side lengths go where. How are we going to do that? Well, let's look back to the original question. In the original question, I've been given a fraction, and that's really, really helpful because we all know that sine theta is equal to opposite over hypotenuse, or sine beta is equal to opposite over hypotenuse. So let's imagine I'm gonna get, I have a good color for this. What's the color gonna be? This is the hardest part. Okay, so opposite over hypotenuse. That means if I'm looking at beta here, opposite will be 2 and the hypotenuse will be 3. And if I'm looking at it in the other triangle, opposite will be 2 and the hypotenuse will be 3. Does it make sense that the 3s are positive and the 2s are positive in this example? Yeah, it does, right? Because 3 has to be positive and both of them are going up. Can we figure out x by using Pythagorean theorem? Yeah, so that's the additional step. We're going to go ahead and use the Pythagorean theorem and figure out what our value for x is. Yes. Sometimes it will not be, like it depends on the question. If it's tan, then we'll have to find another side length. If it's cosine, we'll have to find the other side length. But in this question, if we say x squared plus y squared is equal to r squared, x squared is going to be equal to 3 squared minus 2 squared. X squared is going to be equal to, I guess we should, it says exact values, so we should keep it as a radical. So 9 minus 4, x is going to be square root 5. Now, it's actually going to be plus or minus square root 5. Why is that? It's because depending on where you put your x, on this side, it's going to be a positive square root 5, but on this side, it's going to be a negative root 5. So depending on the triangle, it will change its signs. Yeah. Oh, yep. So for this part, what I did is I took the y squared and I moved it here. And if it's positive y squared, when you move it to the other side, it'll become minus y squared. So it's really x squared is equal to r squared minus y squared. Because on this side of the equation, because if it's a positive here, when you move it over, you have to subtract. Changes the sign. Yeah? R squared is always along the side, it's always positive, but x and y can be positive or negative. Sorry. I can also say y is equal to 2 and r is equal to 3, just so that it's a complete solution. That would be our values for x, y, and r. All right, let's do another example of the same stuff. Question letter B is going to be secant theta is equal to negative 15 over 7. And you're going to notice that negative sign doesn't really belong to either one of the numbers. And I'll explain how you know which one it goes to when we actually get to that part. Okay, so step number 1, if it is a reciprocal ratio, we're going to change it to its primary one. So secant theta is going to become cos. Theta will become beta. The negative sign will become positive. And we're going to flip the ratio around to give 7 over 15. So 4 different steps here. Secant became cosine. Theta became beta. The negative became positive. And we flipped the ratio from 15 over 7 to 7 over 15. Any questions about that? Okay, go ahead and use your calculator to figure out what the cos inverse of 7 divided by 15 is. Round it to the closest whole number. And I got 62 degrees. Now, according to the CAST rule, C-A-S-T, this is like saying, where is cosine negative, right? The original question is secant. Secant's related to cosine. So we're really trying to figure out where is cos negative. Everything is positive here. Cosine is positive here. Cosine is negative here. And cosine is negative here. So we're going to place the 2 arms in quadrant 2 and quadrant 3. Okay, so quadrant 2, quadrant 3. Not even close. Do those kind of look the same? Kind of. Go with it. Once you've drawn your terminal arms, go ahead and label your related acute angle and figure out what theta 1 and theta 2 is. That step, by the way, is the same as type 2, what we did yesterday. You guys, I'm not happy with that arrow, but you know what? I just can't. I'm happy with that. Okay, stop obsessing. Just keep going. This is beta. This is beta. Theta 1 is going to be like this. Theta 2 is going to be all the way around like this. So theta 1, the measurement is going to be 180 degrees minus 62. And that's going to give us 118 degrees. And then theta 2 is going to be 180 degrees plus 62. So what's that? 12, 13, 14, 242. You guys get 242 degrees? All right, so that is just the regular stuff that we did before. Now what we need to do is we need to figure out what X, Y, and R are. So I'm going to go ahead and draw my triangles in the same bow tie structure that we have been drawing it in. I'll fix that arrow later. It's bothering you like it's bothering me. Okay, maybe I'll just do it now. No. Okay, we'll figure it out later. Let's go ahead and try to label as many things as we can. So for labeling my side lengths, I actually look at my beta ratio. So I know cos is adjacent over hypotenuse. That means your adjacent side length is going to be a 7. It's going to be the same for both of them. And your hypotenuse is going to be 15. However, is that 7 going to be positive or is it going to be negative? Yeah, and that's why in the original question, the ratio was negative, because the negative sign actually belongs with the 7, because the 7 in this case has to be the negative number. So we're going to put the negative there. And what are we trying to solve for? What letter? Y. So we're going to go ahead and do the Pythagorean theorem for y. So again, x squared plus y squared is equal to r squared. Y squared is equal to r squared minus x squared. And then just go ahead and solve this. 15 squared minus negative 7 squared. Y squared is equal to 15 times 15 minus 49. So I'm getting 176. Could we reduce that? Probably. All right, reduce this. It's going to give me 88. So 176 can be broken up to 88 times 2, which can be 44 times 2 times 2, which can be 4 times 11 and times 2 times 2. So it's going to be 4 root 11. I mean, now that we've gone through the radicals unit, we should reduce our radicals. I know you probably don't remember it right now, but I'm going to say, yeah, like good format would be to reduce the radicals as much as possible. So this is going to be plus or minus 4 root 11. And the reason I knew how to do that is because it said exact values. So I had to remember that I can't find decimal places. Okay, so does it make sense that y is plus or minus? Well, yes, because on this side over here, that's going to be positive 4 root 11. And on the bottom over here, it's going to be negative 4 root 11. So yes, it makes sense that y is going to be both. And then we'll just list the rest of them as well. So x is going to be equal to negative 7. And r is going to be equal to 15. And that's our final answer. But yeah. Sure, yeah. So what I did was I just took 176 and I divided it with my calculator. So I got 88 times 2, like root 88 times root 2. Then this I changed to, I can't remember, was it 44 times 2? So I did 44 times root 2 times root 2. Then this I did root 4 times root 11 times root 2 times root 2. And then the square root of 4 is just a whole number 2. these two can combine to give you another whole number 2, and this is just root 11. So 4 root 11. You're telling me you don't remember anything from unit 2? Oh, you did it a different way? Well, I'm pretty sure this is how I taught it. Okay, so sine theta is equal to -3/8. Theta is in the third quadrant, so they're making the question easier because now we don't have to use CAST and figure out what the quadrants it's in. They're telling you for sure it's in quadrant number 3. And they want us to find the exact value of secant theta and also find theta and also include a sketch. So what we can do first is what we're kind of used to doing, which is let's figure out what beta is. We're going to leave sine as sine. We're going to change theta into beta, and we're going to make it into positive 3/8. And then we're going to use our calculator and just go sine inverse 3 divided by 8, which gives us 22 degrees. And then the question said, draw your line in the third quadrant. So I'm going to draw it here. Does it make sense that sine is negative in the third quadrant? It does, right? Because the only thing that's positive here is tan. I'm also going to put my beta in, which is going to go right in here. Okay, so the question says, figure out what theta is. Let's go ahead and do that first. Jeff? Yeah. Yes. Yeah. There's only one theta, so we're not going to call it theta 1 or theta 2. It's just going to be theta is going to be equal to 180 plus 22. And so therefore, theta is going to be equal to 202 degrees. Yeah. Because in the question, it says theta is in the third quadrant. So yes, theta does exist in 2 different quadrants, but in this question, we just are looking at the third quadrant. Yes. Yeah, if it tells you which one to draw it in, you don't draw the other one. So we figured out beta, we figured out theta, we've done part of the question. We now need to figure out the exact value of secant theta. So it's not like we can use our calculator to figure it out. If it's the exact value, we're going to need like a number divided by a number. The way we're going to do that is we're going to turn this into a right angle triangle. And we're basically going to find all the side lengths, just like we did before. So remember, sine is opposite over hypotenuse. That means opposite is the number 3, and the hypotenuse is the number 8. And which one of these numbers will be negative? The 3 will be negative, yeah. Oh, it really depends. Like it depends on where the line is. So if the line is going down, that will be negative. Yeah. And now we're going to figure out what x is using the Pythagorean theorem. So x squared plus y squared is equal to r squared. X squared is equal to 8 squared minus negative 3 squared. X squared is equal to 64 minus 9, which is going to be 55. So x is going to be equal to technically plus or minus root 5, although in this question, it's only going to be negative root 55. Can we reduce 55? Well, we can split it up into 5 and 11, and that doesn't really do anything. So it would just be positive or negative root 55. Okay, so what was the point of us figuring all this out? Why did we do it? Because now we can actually use this information and finish off the question and figure out what secant theta is. So let's recall, secant theta is related to cos theta, right? So I'll start with actually figuring out what cos theta is, because that's always easier. Cos theta is equal to adjacent over hypotenuse. That means secant theta is going to be equal to hypotenuse over adjacent. Okay, so now we're going to go to our triangle. We're just going to figure out the hypotenuse is 8 and the adjacent side length is negative root 55. So the answer is just going to be secant theta is equal to 8 over negative root 55. Are we allowed to have a negative if there's a theta there? Only for beta, it has to be positive. So you're allowed to have this. That would be your final answer. Yeah. Do we have to move the? Oh, no. I usually just want the rationalized when it's like a final answer, like 1/√2 or something. For this, you don't have to. If you wanted to, you could. Yeah, I actually didn't take off any marks for the rationalizing because I know there was a lot of confusion, so I just left it, I think. All right, so that's the end of that. Your homework is on the bottom of the page, so I'll show it to you guys at home. We're gonna do one other little thing before we're done. I think you're gonna like